Welcome to the unit on hypothesis testing. In this unit, we will be looking at key concepts through review exercises. The objectives for this session are to review previous topics through exercises, namely, find probabilities associated with the binomial distribution using formulae, tables, and Excel, and suggest a suitable model for a given random variable x. Pause the video and have a go at these review exercises. When you are ready to view the next set of exercises, press play. Now pause the video again and have a go at these review exercises. When you are ready to view the solutions, press play. In an experiment or survey, when carrying out a number of trials, a random variable x can be defined to represent the number of successful trials. The variable x can be modelled by a binomial distribution b open bracket n comma p if the number of trials n is fixed, there are two possible outcomes, the probability of success p is fixed, and trials are independent of one another. If a random variable x has binomial distribution b open bracket n comma p, then its probability mass function is given by probability x equals r equals n choose r times p to the power r times 1 minus p to the power n minus r. N is sometimes called the index, and p is sometimes referred to as the parameter. N choose r equals n factorial all over r factorial times n minus r factorial, where of course n factorial is n times n minus 1 times all the way down to times 3 times 2 times 1, and 0 factorial equals 1. Also, if the probability of a success is p, then we can deduce that the probability of a failure is 1 minus p, since there are only two outcomes. Now let's have a go at the first exercise. The random variable x is distributed binomially with n equals 15 and probability p equals 3 over 5. Find in part A the probability that x equals 7, and in part B the probability that x is less than or equal to 1. So let's solve part A first. We're simply going to apply the formula and plug in the various values of n, p and r. So here we have r equals 7, n equals 15 and p equals 3/5, and all of these have been plugged into our formula. And tidying up, and calculating gives us that the probability of x equals 7 is 0.118 to 3 significant figures. And now for part B. We are required to find the probability that x is less than or equal to 1. So let's solve this. The probability that x is less than or equal to 1 in our example is equal to the probability that x equals 0 plus the probability that x equals 1. And again, if we plug in the particular values of r, n and p, we obtain for this expression, when r equals 0, we have r equals 0, n equals 15, and p of course is 3/5. Here we have r equals 1, n equals 15, and p equals 3/5 again. And then tidying up. And calculating gives us that probability x less than or equal to 1 is 0.0000107 to 3 significant figures. And now for exercise 2. We're going to solve exercise 2a first. The probability that a randomly chosen member of an A-level maths class also studies A-level physics is 0.6. A random sample of 10 members of the class is taken. Suggest a suitable model for the random variable x, the number of members in the sample who are studying A-level physics. So let's solve this. Notice there are two possible outcomes. So the variable x can take two values, taking A-level physics and not taking A-level physics. We also have that the number of trials n is equal to 10. And the probability of a success, p, equals 0.6. So we plug that in to our distribution, or our notation. X is distributed binomially with n equals 10 and p equals 0.6. And of course we're assuming each member is independent. So here's our model. And now for part B. We are required to use our model to calculate the probability that exactly 7 members in the sample study physics. So let's solve this. We have that the probability x equals 7 is as given here. So n equals 10, r equals 7, and p equals 0.6. And these have all been plugged into our formula. Tidying this up, and tidying up some more, and calculating gives us that the probability that x equals 7 is 0.215 to 3 significant figures. And now let's solve exercise 3. Using the extract from the binomial table on your screen, find the probability that x is greater than or equal to 4 for the binomial distribution x distributed binomially with n equal to 5 and p equal to 0.2. So let's solve this. So in the table we've highlighted the column for p equals 0.2 and the row for r equals 3 in the section for n equals 5. You may be wondering, why have we highlighted the row for r equals 3 when we're asked for the probability that x is greater than or equal to 4? Of course, the probability that x is greater than or equal to 4 is 1 minus the probability that x is less than or equal to 3. And this is why the row for r equals 3 has been highlighted. So from the table, we have that the probability x less than or equal to 3 is 0.99328. Notice that this is where we have n equals 5. Here is r equals 3, or little x equals 3. And here is p equals 0.2. And the intersection of the row and the column occurs at 0.99328. But as we mentioned before, the probability that x is greater than or equal to 4 is 1 minus the probability that x is less than or equal to 3. And this is equal to 1 minus 0.99328. Which equals 0.00672 to 3 significant figures. So far, in Excel and from our tables, we've looked for the probability that x is less than or equal to a little x for our variable capital X distributed binomially with certain parameters. And as you can see, that formula is on your screen, which we would type in Excel. We are now going to look at something slightly different. This time in Excel, we're going to try and find the smallest r value with probability x greater than or equal to little r, less than a given value of alpha for x distributed binomially with parameters n and p. And for this we will type the formula given on your screen, equals binom.inv open bracket np 1 minus alpha close bracket, and then add 1. So let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example part A first. The probability that a spinner lands on blue is 0.2. A player has 14 spins. We are required to find the probability that the player obtains fewer than 2 blues. So this is similar to the previous exercises we've looked at, and we're going to use the same formula in Excel again, or if you've been using your calculator, do practice on your calculator. So let's solve this. We set up the problem first, so let x equal the number of blues in 14 spins. Therefore x is distributed binomially with n equal to 14 as shown here, and p equal to 0.2 as shown here. So therefore in Excel we type equals binom.dist open bracket x equal to 2 positioned here and here, n equal to 14, and p equal to 0.2, with commas separating the figures. And so from Excel we obtain that the probability of x less than or equal to 2 is 0.44805. And now for part B. We are required to find the probability that the player obtains more than 3 blues. So let's solve this. Let x equal the number of blues in 14 spins as before, and we have that x is distributed binomially with n equal to 14 and p equal to 0.2. We're looking for the probability that x is greater than 3. This is equal to 1 minus the probability that x is less than or equal to 3. So in Excel we need to type equals binom.dist with x equal to 3 positioned here and here, n equals 14 positioned here, and p equal to 0.2 positioned here, and commas separating the figures. And so from Excel we obtain that the probability of x less than or equal to 3 is equal to 0.69819. Therefore we have that the probability of x greater than 3 equals 1 minus 0.69819. And this equals 0.30181. And now for part C. The school wants to use the spinner in a competition at the school fair. However, the head teacher wants the probability of winning a prize to be less than 0.1. If each player has 14 spins, find the number of blues needed to win a prize. So now in Excel we're going to use the formula equals binom.inv in order to find the smallest value of r, which is going to satisfy the required property. So let's solve this. Again, we let x equal the number of blues in 14 spins. And of course, x is distributed binomially, with n is 14 and p is 0.2. We also let r equal the smallest number of blues needed to win a prize. And therefore, from the requirements of the head teacher, we have that we need the probability that x is greater than or equal to r must be less than 0.1. And so we plug in the relevant values. Equals binom.inv, open bracket, n equals 14, p equals 0.2, and 1 minus alpha equals 0.9. When we type this into Excel, we obtain 5. So therefore, r is equal to 5 plus 1, which is 6. Therefore, 6 or more blues will win a prize. This brings us to the end of this session. If you have understood its contents, you should be able to find probabilities associated with the binomial distribution using formulae, tables, and Excel, and also suggest a suitable model for a given random variable x. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.